Okay, so if you look at these last ones, here, the 485, these zeros are not significant, so we just, they are not going to be significant with 3 sig figs, so we just stop at 485. And here we round to 301. And again, the difference here is that because this 2 is written here, 5002 is more than 5, so we round up to 301. And in this case, 50 was exactly 5. If there had been a string of 000, we would have still rounded down. But if there's anything after that 5, then we round up. So the next thing that we're going to look at is the use of exact numbers. When we're talking about significant figures are for measured values. When we're going out and we're measuring and we're getting all the digits we're sure of and one with some uncertainty. But there are other kinds of numbers that are exact numbers. Exact numbers are numbers that have no uncertainty. They have no uncertainty because they are not measurements. These are things like counting numbers and definitions. So, a counting number. How many students are at this table? 1, 2, 3, 4. There is no uncertainty. There's not maybe 3 students there and maybe 5 students there. There are exactly 4 students because I can count them. So there's no uncertainty there. And definition numbers have no uncertainty. You're used to measuring things in the metric or in the English system. So if we measure something in inches and I want to change it into feet, how do I do that? Divide it by 12, because we know there are 12 inches in 1 foot. Are there maybe 13 inches in a foot? No. Are there 9 inches in another foot? No, there are exactly 12 inches in a foot. Now, back in the old days, they did really measure that with their feet, and feet were different sizes, and that's when they came up with a standard ruler with the 12 inches in 1 foot. It's just like in the metric system that we're going to be using, there are exactly 100 centimeters in a meter. There's not maybe 98 centimeters or 103 centimeters. It's exactly 100. So because those are exact numbers, they have no uncertainty, and we don't have to worry about them as far as significant digits. So now, what happens when we start to combine numbers where we are mathematically combining measured values? Well, we have rules for each type of mathematical operation. For addition and subtraction, we round in the place for the value with the most uncertainty. That's the number whose last significant digit is the place furthest to the left. Now, this rule makes no sense to me in words, but when you look at it with examples, it seems better. So we have 106.7, and we're adding to it 0.25. So when we look at this, our calculator says 106.95. And that's what we're tempted to write down, but that is not correct. We have to think about significant digits. So the way I like to do this is line the digits up on top of each other, because then I can see how this works. 106.7 and 0.25. Now, when I look at them this way, 106.95, and I look at them stacked up, we look at the place that has the least significance. The number whose last significant digit is in the place furthest to the left. So if I start lining them up, this has a significant digit in the hundredths, but this one doesn't. So the tenths place is where all of my numbers have a significant digit. So I have to stop in the tenths place. Since I have to now stop in the tenths place at 106.95, what do I have to do here? I'm going to round to the tenths place. So what do I do with this 5? Do I go down or do I go up? Why down? 9 is an odd number. I round to even, so I have to go up. So I would report 107.0. So that's what I would report, because I round to even. Okay, let's look at the next one. 45.9 plus 62.3. I get 108.2. So what do I do with that? I round down to what? I don't do anything with that. Where is the last significant digit in this number, 62.3? In the tenths place. Where is the last significant digit in this number, 45.9? In the tenths place. Where should I put the last digit for the answer? In the tenths place. So do I round? No. I leave it alone. I think this is the most confusing and hardest significant figure rule, is the one on addition and subtraction. So you have to look at the place, and then you start kind of from the left, and where is the last significant digit for each of them? It's in the tenths place, so we stop in the tenths place. Yes, there are. Isn't that great? Because the rule about how many sig figs has nothing to do with adding. You're remembering the rule for addition. For multiplication. Addition and subtraction, you look at the place. Multiplication and division, you look at the number of digits. So, yeah, I think this is the hardest one. This is the one my students have the most trouble with, and this is the one that I have to stop and think about every time, even as much significant figure calculating as I've done. Okay, let's look at this one. 35.4 minus 30.5. Well, calculator says 4.9. Now, when I think about this and I line them up, 35.4 minus 30.5, I get 4.9. And I look and I stop in the tenths place. So now, Ryan, if you're thinking of that, I had 3 significant figures in each of these numbers, and I only have 2 in my answer, and that is correct, because I am stopping in the tenths place, because that is where the last significant digit was for both of them. Now, let's look at this one. 112 minus 90. Well, what does my calculator say? 22, right? But now when I think of this in terms of measured values, and I have 112 minus 90, I get 22. But where is my last significant digit in this number, 112? It's in the ones place, 112, the 2, right? Now here, where is the last significant digit? The 9, right? The 0 is not. So I have to stop in the tens place. So I have to stop here with this 2 in the tens place, so I report 20. So you are looking at the place of significance. And if you think about it in a non-mathematical kind of a common sense way, if I'm only measuring to the tens for one measurement, and I'm measuring out to the tenth for another, when I add them together, I'm still only good to the tens because that's how the one measurement was made. Doesn't it make more sense if you just think of it in words? Not really, I can tell by your faces. Well, that's the rule. We're going to practice. Okay, let's finish the rules then. Multiplication and division, You round to the number of significant digits that has the fewest. This is the easier rule, in my opinion. So we start off 50.5 times 12. Calculator says 606. How many significant digits in 50.5, class? How many in 12? 2. So how many can I report? 2. So I would round to 610. 103.37 divided by 20.5. Calculator says 5.042439. So now we have to round properly to significant digits. How many significant digits in this number? 5. How many in 20.5? How many in my answer? 3. 5.04. Up here, 0.004678 times 1.23456. I have no idea what that's equal to. Grab your calculators and figure it out. Tell me all the digits you get. So now, that's what the calculator says, and we don't report what the calculator says. So I have how many significant digits here? Class, 4. How many here? 6. What's smaller, 4 or 6? 4. So I can have 4 in my answer. So I would report 0.005775 because 2 is less than 5, so I round down. I leave it. This last number on my calculator, 179,500. How many significant digits are in this number, 359? This is a trailing 0 with a decimal point written in the number, so it's significant. So 4, and how many here? 2. How many in my answer? 2. 180,000. So you can see that the rules are different for different kinds of math. So we're going to pause here and do practice problems 1 through 3 in the significant figures practice.